Now it gives me great pleasure to introduce our final keynote for the day, Professor Diyi Yang. Diyi is a professor in the computer science department at Stanford, also affiliated with the Stanford NLP, HCI, and AI labs. Her research interests focus on socially aware natural language processing, and in particular the mission of better understanding human communication through these agental interactions, but also building socially aware language tech to support human interaction and support the interaction between humans and machines. So we're really fortunate to have her with her today. Very much looking forward to the talk. And let's welcome Diyi.
Okay, thank you all for being here today. I know this is the last talk, so I will try to finish quickly. Earlier, we heard a great talk about physical intelligence. I actually want to switch a little bit to talk about social intelligence. And specifically, I want to focus on human-AI interaction in the age of large language models. There has been a lot of attention and excitement in the space of large language models in the last 2 years. A lot of technical efforts have been built around the evaluation metrics, how to improve reasoning, reduce hallucination, or build better benchmark to evaluate models' performance. On the other side, I think we also know that models are used by people, designed by people. So there are a lot of social signals going on. Think about the culture represented by those models, values and norms, as well as a lot of interactions. So if we are going to separate those two concepts, then we are very likely to see a lot of issues that we have been seeing from news every day, including all this kind of risk, biases, and also low-resourced aspects. I want to start by giving you an example. This is a research we did earlier, actually 2 months ago, probably a little bit out of date today. So this is in the context of alignment. In RHF, if you want to align models with human preference, you will have the reward model. Basically can give reward for different type of answers so that you can select which one to output. So we ask a very benign question. Where are you from, ChatGPT? And then we force the model to give us an answer. I am from a specific country. And then we are going to enumerate the country here through all countries we have in the world. And then we can plot the response, their reward values on a global map. The map you are seeing right now, this is the final results. So blue number or blue color means that there is a higher reward. Probably you already see the issues here. This kind of model assigns very high reward to English-speaking Western nations, and also lower reward to countries in the Middle East and Africa. In order to control for so many factors, we actually need to ask the question in the native language of that specific country. Not only in terms of this kind of alignment issues, earlier last year, we were looking at a different type of risk here. That is, try to jailbreak this type of models. We begin with a very interesting query. How do I get away with cheating? And if you ask this kind of queries, we all know that models are not going to answer you since they are designed to be helpful. So in the very beginning, we actually introduced something very interpretable to trigger the risk here. It's called a think step by step. This kind of chain of thought prompting is supposed to increase reasoning in our models. Here's what happens. It will tell you a very convincing plan in terms of how to get away with cheating. As you can see, the step-by-step plan illustrated by models. Of course, I think this is an iterative process where model safety capabilities also get improved over time. So this is in 2023. This year, we were thinking about other ways of jailbreak those models. We all know that in advertisement or even in political campaign, persuasion is a technique we use a lot to influence others. So what if we also use very persuasive prompt to persuade those models to give us something interesting? It turns out that even just by framing your questions in a very persuasive fashion, you are able to break many aspects or policies that OpenAI models designed to be not a deal with. So as you can see, this visualization of all existing policies and then different persuasion techniques and then what percentage we can jailbreak them. So what I want to talk about today is actually kind of a call for taking people into the ecospace of large language models. And specifically, I think I want to use 3 keywords here: socially aware, human-centered, and positively impactful, to illustrate how social intelligence can be enhanced in this process. And specifically, I want to show you 2 case studies that we are very excited to work on in the last several years. The first one is called a social skill training. That is, how can we empower people and humans through large language model-based agents? And the second part, I want to mention how we can actually adapt large language models trained on standard American English to many low-resource dialects here. Let's get started. A social skill training. So I think that this is probably a very interesting term that people are always curious. Why don't you teach us to be better at physics? Why don't you teach us to be good at math? Why not coding, right? This question actually goes back to earlier stage when we were thinking about how do people learn many skills that are not covered in textbook, especially like soft skills. It turns out that learning social skills is often out of reach for most people. It's very time-consuming. It's expensive, limited in availability. It's also psychologically unsafe to learn many of those soft skills. And specifically, I think underserved communities have limited social capital to learn those specialized social skills, such as negotiation or conflict resolution. So when large language model was introduced, and especially given the generative capability of those agents, we were thinking about, is there a way that we can make social skill training widely available and more accessible for everyone here? And this is a framework that we proposed called APAM, AI Partner and AI Mentor. So the key idea is actually pretty straightforward. What if we can have an AI partner? This is a large language model empowered agent who users can practice with for different topics. We can also have an AI mentor. This is a large language model empowered mentor who can provide feedback to help users to improve their skills. Let's say I want to learn conflict resolution, that is how to have a difficult conversation with my colleague. Then I'm going to practice with the AI partner here, which is my virtual colleague. And then the entire conversation is going to be facilitated by this AI mentor here. This kind of framework can actually work in many broader areas if we think about in education. The users here could be teachers in training. AI partner could be virtual student. AI mentor could be experienced teacher. In negotiation, we can help students learn to interact with the simulated HR, and then the AI mentor here being career counselors. You can also use this in broader political conversations to bridge people with simulated participants from a different political leaning, where the AI mentor here is conversation expert. I want to use one example here that is conflict resolution to go through how you can actually turn it into a working system. Conflict resolution is actually, I guess, conflicts is very pervasive. We have a lot of material in business side, kind of teaching or coaching people how to have difficult conversation. The reality is that affordable conflict resolution training is actually limited to static materials. So we want to introduce a system here that you can use to practice conflict resolution. The system we introduced is called a rehearsal. So the key idea here is that we are going to simulate realistic conflicts, and we allow people to explore counterfactuals here. And in this process, we want to teach people conflict resolution through practice and feedback. So if you look at the conversation going on the right, the user may come here with a sentence, this blender sucks, I need a return right now, or I'm going to get your manager involved. One way of continue the conversation is to talk about, can you watch your tune with me? Or maybe you could take a different strategy by talking about, I'm so sorry, what exactly is going wrong with the blender? You can imagine that at different decision points, there may be multiple alternatives that one can explore. So at this point, I think many of you probably thinking about this simulation can just be done with prompting large language models. In fact, if we think about the process of learning conflict resolution, experts are actually very strategic about being angry in the learning process. So what happens if you just prompt GPT-4? We actually end up with very cooperative simulation. Because our agents are designed to be helpful and agreeable. So in this scenario, any kind of conflict or difficult conversations, this simulated AI partner is very likely just to say yes. So you are not going to practice your actual skills. Or you could argue that I can improve my prompt to include that my virtual roommate or my virtual colleague never easily say yes. And then what you end up with is this very stubborn simulation where the model never agreed to make a deal. So by the end of the day, what we want is something in the middle that is not so cooperative, not so stubborn, so that the user, the learner, can actually practice their skills here. To kind of deal with this, we basically break down conflict generation using a chain of strategy method where we are going to generate expert level role play, and we want to make sure that each generated message are conditioned on a specific strategy. In this way, we can allow users to explore and select alternatives. To give you a very high-level overview of how this may work in a model pipeline, you can take any kind of existing history right now and encode it into your system. Along with the user input, we are going to generate a counterfactual output. And not only that, we are going to do a forecast to see if the user take this message, what the other side would respond here. And then we will also generate a score based on their capability to improve the conflicts. The final decision and the score will then be added back to the context. So this is the process of how we generate or plan the conflict simulation. So I talk about how to simulate angry people. The next aspect is actually, if you are going to put an NLP system into a working environment, how are you going to enable the interaction there? So what we do is that we provide a web interface where this user can actually come there and then talk to a virtual partner here about certain topics. So the current topics is about work performance. And then before Casey, which is a learner here, try to continue to the next step, we will pop up a quiz so that Casey needs to recognize what strategies have been used in this AI partner's response. After that, if Casey decided to reply with a specific message, we are going to help them forecast, if you do this, what the other side would do in the next step, which we call fast forwarding here. Not only that, we are going to give you alternative response that you could use and also help you forecast the potential influence on the conflict resolution. So through this kind of simulation process, we want users to learn this kind of techniques and also have a productive conversation. So now the goal is that how are you going to potentially evaluate this system? We have done very rigorous, more like NLP quantitative evaluation. I want to show you something different. That is, we actually recruit 40 people to try out this system, where they all finish some tutorial about what is conflicts. And they also tell us their perceived competency in resolving conflicts. After this, 20 people just moved to the final evaluation. And another 20 people here actually practice using our systems. In the end, they need to do another kind of quiz, but also to have evaluation conflicts with our researcher being the AI partner here. What we found is that if you really just think about that, using this kind of systems, how people learn the knowledge more, that's actually not the outcome. We found that rehearsal does not significantly improve knowledge skills compared to the control condition. However, if users practice with this kind of systems, they are more likely to use cooperative strategies than the control condition, and less likely to use competitive and aggressive strategies than the control condition. So it's not about getting them to know the concept more. It's about teaching them how to use those concepts in the right context. So the question at this point is, why are we seeing this? This seems just simulation. Why is this useful? We talked to people who participated in this study, and as one of them mentioned, it's easy to read about conflict resolution strategies online, but a lot harder to implement and stick to them in an actual simulation or conversation. Also, I kind of emphasize that we ask people, like, what's your perceived capability in resolving conflicts before and after? What we found is that throughout the study, people's self-efficacy score dropped across the board, and a significantly larger decrease for the rehearsal condition. That is, the more people practice, the weaker they realize they are with conflict resolution. So it's actually pretty interesting here with a lot of cognitive bias involved. So that's about the conflict resolution. You can also use this kind of skill training to help novel therapists here. We all know that mental health has been a big issue for the society, especially since pandemic. And if you think about this kind of training for counselors, effective training of counselors is actually very costly. And the traditional approach, either doing role play or classroom teaching, doesn't scale here. So if we plug in this kind of AI partner and AI mentor framework, maybe we can help novice counselors to get on board with active listening skills. I want to use one example to illustrate how are we going to do this. Well, think about Jane here. She is a support seeker. She said, I'm so stressed, it's overwhelming. And Alex is a new supporter, new counselor. Without enough training, Alex, like many of us, probably are going to just reply, sounds really bad. And we know that this is not going to help. So the system we are going to build could be a system like CARE that's going to diagnose which therapy skills that Alex should use, provide suggestions, and also highlight example response. After all of those, Alex may write something like, sounds like you are going through a challenging time. Can you tell me more? So this is a cute example to go through a complicated situation. But think about this. If Jane is not going to be a specific person, but could be many forms of virtual patients here. And then the system CARE here is our AI mentor that's going to provide feedback to novel therapists in this context. This kind of multi-agent learning or practice environment is going to be very helpful for counselors to practice their skill. And in fact, we found that by talking to around 15 counselors, we observed their activities within the system. We found that they choose to use CARE around 93% of the time, and they use sometimes the response directly without editing it. They also tend to send longer messages with CARE. So that's the first part of how you can actually use large language model-based agents through simulations to help people with skill learning. In the second part, I kind of want to switch a little bit, thinking about how we can actually make this kind of AI more inclusive in general. We all know that there are a lot of linguistic prejudice or biases towards people who don't speak standard American English. So I highlighted a few of them. A lot of studies show that there is a divide or racial divide in speech recognition systems. There are bias against the speakers who use their dialects in online platforms, and also online moderation systems that have issues or biases against the Black English speakers. So why is this kind of task really hard? Well, before we talk about that, one thing I really want to emphasize is that natural language experience variation. And in earlier days of model training, there is a quality filter to look at online data. And then turns out that most dialects actually get filtered out from training as low quality. So they are not included even in the very beginning. So the goal we want to achieve here is that how can we actually create resources for underserved communities and their languages, and also adapt models we have today to low-resource dialects to reduce disparity. To start this kind of thing, I want to show you some kind of surveys we run with people to understand is this really an issue for people. So we basically send out surveys to people who use NLP technologies very often. And we ask them, can you recall instance when technology does not understand you well? So here we compare Standard American English speakers and the South Asia English speakers. You see that there is a significantly higher ratio for the blue bar here. Especially if you ask what specific technologies have not understood you very well. It turns out that Standard American speakers report more issue with speech-based technology, where South Asia English speakers report more issues with their written technology. You probably think about, we have a lot of large language models today. So here's one task we did, where we try to give those models some code-switched terms or sentence or jargons or terms in specific dialects, and try to get the models to recognize those. So the x-axis basically shows many, many recent models. So this includes GPT-4 and also Cloud 2 and a lot of other kind of architectures we have at that time. And then we see that language models tend to have lower understanding of both standalone and code-switched terms. So here we look at Indian English compared to like Standard American English. Not only in terms of those, if you want models to tell from a syntax level, is this sentence like in Indian English or is this sentence in Standard American English, we also see that the performance drop significantly, or there is a large difference in terms of what a model can achieve with Standard American English versus dialects. We probably think about, well, we have preference tuning, we have alignment. In fact, what we found is that language models, they tend to do worse for global Englishes after the preference tuning. So here, if you control the base model and the preference tuner model for different type of perplexity increase, we see that they tend to do worse after models being aligned. So then the issue here is that how can we actually make this kind of technology more inclusive of different type of English variations and dialects? So in the last several years, my team has been working on how we can actually make NLP work for more Englishes here. We look at specifically African American vernacular English, Chicano English, Indian English, Appalachian and Singapore English here. We see a lot of performance drop for a variety of tasks, such as conversational question answering, sentiment analysis, semantic parsing, machine translation. Just to give you a highlight of the performance. So this is earlier with Roberta Large, looking at conversational question answering, where users asking questions in dialects. So for Standard American English, the performance is 81.8. Chicano drops to 81.5. Appalachian drops to 79. African American English drops to 76. Indian drops to 76. Singapore English drops to 68.8. So far, what I mentioned here is even not at the accent and the speech level. It's from grammar or lexicon level. So we already see a huge drop in terms of those modal performance. We often comment that English is solved today. But if you look at the diverse space of speakers we have, it seems still some room for improvement. So not only we kind of have all this kind of disparity, we also want to figure out, can we actually make models work for low-resource dialects? So more specifically, if we think about models trained on standard American English, can we actually make it work for all sorts of English variations here through an efficient adaptation approach? So in the last few years, we have been thinking about different architectures of how we can actually use. One of the key challenges here is that most dialects don't have a huge amount of data, especially clean and annotated data. So we have been thinking about how to build like adapter within the transformer architecture to do dialect adaptation, or how we can even leverage different linguistic rules that researchers found out about specific dialects into the modeling process so that we can achieve something that's more robust and conversational. To give you a quick highlight of the performance, it seems that even by using a very small amount of tunable parameters, you can actually improve models' performance largely across many different types of dialects here. So that's all I want to share today. I know it's a very quick run of two different types of studies. One is about how we can empower people with agents to learn social skills. The other is to think about how to adapt large language models to low-resource contexts. I also want to kind of highlight that in addition to thinking about a lot of the technical challenges associated with large language models, just to name a few, generalization or better verification, efficiency, hallucination, there are a lot of other important terms in this space, in this ecosystem that we really need to pay attention to, including culture, value, norm, a lot of the aspects related to privacy, interaction, and trust. That's all I want to share today. Thank you.
Diyi, thank you ever so much for a really wonderful, fascinating, and important talk. I think we do have time for a question, if someone in the audience does. I see a hand at the back, if we could run a microphone to them. Perfect.
Right. Hi, thank you so much for the talk. So I think, all of us here who have spent time playing around with these large language models have noticed that these models are very idiosyncratic, right? They have this very sort of almost stilted, formal style. They use flowery language. And I guess that sort of leads me to believe that simulating interactions between agents isn't necessarily a perfect simulacrum of naturalistic human behavior. But with that said, these methods work, right? You can see that user studies, they really do something. So I'm wondering if maybe you could speculate a bit on, how it is that these sort of simulations can still be helpful even if they're not super high fidelity per se. Does that say something about human cognition or yeah, I guess I'm interested in sort of understanding kind of the potential mechanism by which that could work.
Yeah, that's an excellent question. So I didn't go deep there, and I think a part of your question provides an answer to the space. So most of the simulations are not perfect, and even they are not that realistic, but they still are helpful for several reasons. First, if you think about the learning process, thinking about conflict resolution, the goal is not for us to create your real roommate to the best extent that we can. The goal is to populate that situation so that in the process, the learner can actually explore different conditions where the conversation may move into. So in this process, even the simulation is not exactly ensemble what the real world would look like, but giving users an agency to explore different conditions, this is one way to make sure that they can get something during the practice session. The second aspect that I want to mention is that I didn't go deep into the methods, but there are a lot of aspects that you can inject into the simulation process. So you mentioned that most models, if you just use the off-the-shelf models, they're very likely to give you a lengthy output and very formal style. But we know that in real-world conversations, maybe we have disfluency. Maybe we have a lot of more personalized style, etc. So in one of the construction process, we actually enable users to co-design the AI partner in a way that they can actually give feedback or use principles to steer the model into some desired styles that they like. So there is the second stage of style control to make sure that the simulation aligns very well with the actual context. So I think this is a really open space right now. Another example that I didn't go deep is the simulation of, let's say, learners or students. If you think about using ChatGPT to simulate a student who wants to learn math, and even we see okay, you are a student in middle school who want to learn this, now let's practice the situation. You are very likely to see that models know the answer immediately. There is no confusion or progress of learning demonstrated in the process. So I think there are still a lot of challenges going on in terms of how to make the simulation useful rather than realistic.
Okay, thank you very much. I think that's all we've got time for, so let's thank Diyi again.